I would like to start chapter 4 today after we finish reviewing. So that was one of the reasons why I said, oh, okay, we can skip the quiz today. Today's the 18th. Yes, sorry about that. Page 5.
I'm sorry, 528.
I'm almost there. 528. Number 21. Very good. And we have the square root of 3 times tangent 3 theta plus 1 equals 0. Perfect example. First I have to solve for very good. So tangent 3 theta equals negative 1 over the square root of 3. But this is the same thing with negative the square root of 3 over 3 after I rationalize. Since in this problem, in this trigonometric equation, I have tangent, which is a ratio of two trig functions, I make myself a note that cosine 3 theta can never be 0. Because if I get solutions that make cosine 3 theta 0, I have to exclude them, because then tangent will be undefined. Is that clear? Okay. So I have tangent 3 theta equals this. And now I have to remember what angle is that. First of all, I'm looking at the unit circle, and I know the tangent is negative here and here. So I need to find the reference angle. So this is one angle, and this is the other. But I need to find the reference angle. This and this. And if you remember, I said do not memorize tangent. So for tangent, there are two options. For pi over 6, 1/2 of the square root of 3 over 2. And for pi over 3, the square root of 3 over 2 over 1/2. When I divide this, this will give us the square root of 3, which is not the case. This is not the square root of 3. It's 1 over the square root of 3. So it must be this. So the reference angle must be pi over 6. So then I have two possibilities for 3 theta. We had a similar example in a note some time ago. So what is the first possibility for 3 theta? Can anyone give us the first option for 3 theta? An angle in the second quadrant with a reference angle of pi over 6. Thank you. 5 pi over 6 plus, since we're talking about tangent, I can no longer put 2 pi k. Only for tangent and cotangent, I must put pi k. Where, of course, k is 0, plus or minus 1, and so on and so forth. Now, the other angle in the fourth quadrant with a reference angle pi over 6 as well. Is it clear how we get 5 pi over 6?
Not at all.
Pi, go back, pi over 6.
Okay.
So pi minus pi over 6 is 5 pi over 6.
Okay.
Now I have 2 pi and go back pi over 6. 11 pi over 6 plus pi k. Is this okay?
Okay.
It's not enough, however. These two equations give us 3 theta. We need to solve for theta. What should I do? Yes. So the first equation is theta equals 5 pi over 18 plus pi over 3 times k. This is the first equation. Divide this by, when I divide fractions, I multiply by 1/3. So this times 1/3, this times 1/3, and this times 1/3. And from the other one, I have theta equals 11 pi over 18 plus pi over 3k. If the book condenses them, I'm fine not to condense them. They can be condensed. So here, this is nothing else but this one plus pi. But I'm fine with this, with these two solutions. Very good question. Anything else? Steve, is this okay?
Yeah, I understand.
Okay, good. Other questions? Anyone? Anything else you worked on?
I don't have one in particular, but can we go over another one of the graphing ones we have to do?
Yes, anything, of course. Anything, polynomial or rational or both, of course.
Maybe one of each.
Yes, of course. So let's go back. Those are the end of chapter 3. Would you like to pick from the review, or would you like to pick from the actual sections?
This section, I don't know what's what in the review.
So you want the review?
No, I don't know which problems are which in the review.
Oh, okay. So, for example, page 294. The rational functions are between 77 and 82. And on page 293, polynomial functions are between 39 and 46. So 39 through 46 on page 293, and 77 through 82 on page 294. Any preference, or do I pick, or? '82 is not a good example for this class because the difference of 2 degrees is 2, not 1. And 82, we can only find x and y intercepts. We don't know anything about the function. So don't even bother with 82. It should not be in this class. It should be in the next class. Okay, since you want me to pick, I will pick 79. In 79, we have r of x, which is x minus 2 divided by x squared minus 2x minus 8. What type is this? Yes, it is type 2. So I can already create my chart. I must factor the denominator. So r of x is x minus 2, and the denominator is, very good. Excellent. So then I know the domain. I don't have to write it separately. If you just put it in the chart, this chart or any chart you want to use, it's fine by me. What will be the domain of this function?
All the numbers.
Negative, indeed, -2.
Right. It cannot be -2.
-2 to 4.
Yes, it cannot be 4.
4 to pop.
Indeed. Now I have to ask myself, do these two factors stay in the final function? Because if they don't stay in the final function, then they are not asymptotes. They're not vertical asymptotes. Do they stay, or can I simplify them with something from the top? No, they stay, which means x equals -2 is a VA and x equals 4 is a VA. Since I'm talking about a vertical asymptote, or vertical asymptotes in this case, I like to determine these infinities. I know this is infinity, 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 infinity. No doubt about it. But what I don't know is, yes, in order to find the signs of these 4 infinities, I will be using -2.1, -1.9, 3.9 and 4.1. As close as I could possibly get to the asymptotes, left and right. In the factored form, can you please plug in negative 2.1? What is the sign of the top when we plug in negative 2.1 in the top? Perfect. In the first factor in the denominator. And in the second factor in the denominator. So with three negatives, what is the sign? Good. With negative 1.9, what is the sign of the top? What is the sign of the first factor in the denominator? And what is the sign of the second factor in the denominator? Good. Now we have two negatives. Good. Now with 3.9, what is the sign of the top? What is the sign of the first factor in the denominator? And the sign of the second factor in the denominator? So what is the sign of the outcome if we have one negative? Finally, with 4.1. Positive, positive, positive.
Is it always going to be a reverse, or are there situations where?
No, it depends. It depends.
So it's worse.
Because at each asymptote, I can have this, or I can have this, or I can have this, or I can have this.
So just check all four sides.
Yes. Yep. If you have two asymptotes, yes. Now the end behavior and the horizontal asymptote for type 2. Very good. So y equals 0 is a horizontal asymptote. I only need the x and y intercepts and I'm done. It's not symmetric. It cannot be a symmetric function if it has a vertical asymptote at negative 2 and one at 4. But I will write f of negative x does not equal f of x, and it does not equal negative f of x. And I'll write not symmetric. So I show that I know what I mean. But I don't have to actually put it in. It's impossible for the function to be symmetric. Okay, so now the X intercept. How do I get it? For any function. Good. So a fraction is 0 only when the numerator is 0. So x minus 2 is 0, which means x equals 2. I have 2 and 0. And now how do I determine the y-intercept? And that's it. Yes, so r of 0. When you plug in 0, it is better if you plug it in here, not in the factor form. It's easier. So what is the value of the function when x is 0? Very good. That's it. That's all we need. So I summarized everything in the chart, and now I'm ready to graph the function. What do I have to graph first when I graph a function with asymptotes? Yes, the asymptotes go in first. This function has three asymptotes. One at negative 2 for x equals negative 2. The other one is x equals 4. And this is an overkill because the axis is already there, the x-axis. And now I'm looking at my chart and trying to make sense of it. So let's do it together. From approaching 0 towards negative infinity, drops to negative infinity on the left-hand side of the first asymptote, but it cannot cross the x-axis. There is no x-intercept here. So it's coming from below. Below, going to negative infinity. In the middle, I have 0, 1/4. I'm going to say this point. I have 2, 0. I'm going to say this point. So now I read the middle part. It's coming from positive infinity. It crosses the y-axis at 0, 1/4. It crosses the x-axis at 2, 0. And it drops to negative infinity on the left-hand side of the second asymptote. On the right-hand side, it's coming from positive infinity and it drops to 0 without crossing the x-axis because there is no x-intercept. So this must be it. Now with the graphing calculator, we check, go to y equals. Don't forget to put everything in parentheses. The top is x minus 2. And the denominator is x squared minus 2x and minus 8. There is no need to put the second function in, but let's put it in because this calculator gives it in different colors. So now I will say go to zoom and choose the standard viewing window. Let's see what happens. Here it comes. Okay. Yes. If you have any doubts about this area, I would change the viewing window to -1 to 2 with -1 and 1. And I will just graph that area. It crosses at 1/4 and it crosses at 2. Maybe it would have been better to change 2 into 4. Here it is, crossing at 2. It's a straight cross because there is only one multiplicity 1 for x equals 2. And here it crosses at 0, 1/4. And this is 1. So this is 1/4. So no doubts there. Any questions? Any questions? Is this okay? Is this good enough? Okay. Now, the difference between this and type 1 is this number. That's the only difference. This number will be the leading coefficient over the leading coefficient instead of 0. The third type is more difficult because it requires us to determine a slant asymptote, and it does not have a horizontal asymptote. So if you want a function like that, you can choose 80. 80 is type, I'm sorry?
I'm sorry, for type 2, the horizontal asymptote is always 0?
Yes. At infinities, because the numerator is very small and the denominator is very big. Yes, every time the degree in the denominator is bigger than the degree in the numerator, at infinities, the function approaches 0. Okay, do we need to see type 3? Okay, very good. So let's look at problem 80. So problem 80 on page 294. R of x equals 2x squared minus 6x minus 7 divided by x minus 4. It is type 3. And it will have no horizontal asymptote but slant asymptote. I get the chart going. What is the domain of this function? Very good. Very good. Perfect. So let's look at this function one more time and see if we can factor out the numerator. Do you think that it will be a factor of x minus 4 in the numerator? No, because the free term is 7. There is nothing that I multiply 4 by to get 7. So now my next question is, do you think that x minus 4 as a factor will disappear from the denominator? No. So then what do I conclude about x equals 4? For sure. It's a vertical asymptote, and these are infinities. What I don't know is their sign, and I will determine their sign with 3.9 and with 4.1. However, I would like to factor, if possible, the numerator. If it's not possible, then we have to use the quadratic formula anyway. So 2 times -7 is -14. And to get a -6, it's not possible. So 2x squared minus 6x minus 7 is not factorable. Cannot do anything to it. So in order to find the signs, I have to plug in 3.9 here, and then 4.1 here and here. Since I cannot factor, I recommend, let's punch it in the graphing calculator, because it's easier to find those signs. So in y equals, clear, and in parentheses I have 2x squared, and that's minus 6x and minus 7. And divide by, in parentheses, x minus 4. And now all I want is to go to second and table and punch in 3.9 and just look at the sign, and punch in 4.1 and look at the sign. Good. So negative on the left hand side and positive on the right hand side. Now I would like to determine the slant asymptote. Of course, it's not symmetric. F of negative x does not equal f of x, does not equal negative f of x, not symmetric. You have to write this down. And I understand why you didn't plug it in. A function with a vertical asymptote at 4 cannot be symmetric. Not possible. If it had a vertical asymptote at 0, that's possible. Who knows? And then I will have to calculate f of negative x, but not in this case. How do I determine the slant asymptote? In this case, 2 methods work. Which methods?
Like the top.
Right. The long division works, and also the synthetic division. Both of them work because the denominator is x minus 4. So then which method do you want to apply? It doesn't matter. Long division or synthetic division? Okay, very good. So then I have 2x squared minus 6x minus 7 and x minus 4. X times what is 2x squared? Very good. We go back, distribute, and now we change the sign. So 2x times x. Yes, and I subtract. 2x times negative 4. Yes, because I subtract. I change the sign. So I perform the operations I see. What now? X times what is 2x? Yes, positive 2. 2 times x is 2x. I subtract. And 2 times negative 4 is negative 8, but I have to subtract. Can anyone give us the simplified form? Or I should say the answer after we divide. So 2x squared minus 6x minus 7 divided by x minus 4 equals?
2x plus 2 plus 1 over x minus 4.
Excellent. Which of all this that I see here is the slant asymptote?
2x plus 2.
Yes. Why? Because this will approach 0 as x approaches infinity. That's why that doesn't count. So then I'll go back to my chart, make myself a note. Y equals 2x plus 2 is a slant asymptote. And how does this line look like? Does it look like this? Or does it look like this? Okay, which means what is the end behavior of this function then? Because the function must follow the slant asymptote. So this is, and then, exactly. So it must go from negative infinity to infinity. Because it has to follow the asymptote, like the function would had followed the horizontal asymptote. So I need f of 0 or r of 0. 0, 0, 0, 7 over 4. So 7 over 4. But I also need one more thing. I determined the y-intercept when x is 0, but I did not determine the x-intercepts when y is 0. So x intercepts when y is 0. So should I put the shades in the back? I don't know if you can you see? Should I or not? So how do I determine the x-intercepts for this function? So it's a fraction. When is a fraction 0? This is the fraction when the numerator is 0, which is 2x squared minus 6x minus 7 equals 0. How do I solve this equation? Yes. Negative b plus or minus b squared minus 4ac 56 divided by 2 times a. I will punch this in the calculator to see what I get. So in clear what you have, not necessarily, but I had to. So I have 6 plus the square root of 36 plus 56, close the parenthesis, outside parenthesis, and divide by 4. So that's one x-intercept. The other x-intercept is negative 0.9. So negative 0.9 and 3.9. Wow. Interesting. Let me see if I made a mistake. We'll see in a minute with the calculator. So negative b plus or minus b squared minus 4ac. 4 times 2 is 8. Is 7 times 8 still 56?
Yeah, 8 times 8 is 64. Yeah,
7.
7 times 8 is 56.
Okay, just making sure. Okay, so 36 plus 56 in parentheses divide. Oh, that's what I got. Okay, we'll check in a minute. So I had negative 0.90 and 3.90. Weird, but I don't know. I haven't graphed it yet. We just picked the problem. Okay, so when I graph a function with asymptotes, what do I have to graph first? Yes, all the asymptotes, vertical or otherwise. So it has a vertical asymptote at 4. And it has a slant asymptote 2x plus 2. Okay, I was checking the slant asymptote also. Okay, so when x is 0, I have to graph y equals 2x plus 2. When x is 0, how much is y? When y is 0, I move 2 to the other side and I divide by 2. Very good. Very good. So now I'm looking at my chart. It says at negative 0.90, right here, there is an x-intercept. It also says that 0.7 fourth. This is not 2, very close to 2 right here. And 3.90. Not at 4, but close, very close. Okay, ready? Good, it makes sense. So from approaching the asymptote at negative infinity, it goes up to cross at negative 0.90, goes further up to 0.074, and it goes down now to 3.90 and approaches negative infinity on the left-hand side of the asymptote. So I don't know if it turns here. I doubt. I think it continues a little bit longer, or higher, I should say, and then it does this. Again, the moment of truth will be in a minute after we graph it with a graphing calculator. I believe that this is the case. There is a maximum, a local maximum there. Now, on the other side of the asymptote, as you know, the function, no function connects infinities. It has to connect with a minimum infinities. So there must be it between those two asymptotes. There is no doubt. Good. So now with the graphing calculator, we have our picture, we have our idea of the graph, and now we go to y equals. I already have the function in there, but I have to add another function, which is
2x plus 2.
very good. Because the calculator is not as smart as it should be. So now zoom 6. We'll see if this is a good viewing. Here it comes. Yes. Hey, turn. Okay, it did. We do not see the top part, so I have to adjust the viewing window. So let's go to window. -5 to +5 or 6. +6 would be good enough. Y minimum -4 is good enough, and Y maximum I have no idea. I'm going to put 50 with a scale of 10 and see what happens, and just graph. Okay, it appears that I went too far. That's too much. So 1 to 30 will be enough. So I'll change it one more time. Y maximum, I'm going to put 30, and the scale of 5 is good. And now graph again. Okay. Good. And here comes the slant asymptote. See how close it is. Okay. The graphing calculator does not present the vertical asymptote, which we know it's at x equals 4. So now I'm going to try to find this maximum and try to find this minimum. So I see that the maximum is definitely between 4 and 4.98, I'm going to put. So second in calc, I want a maximum between 4 and 4.98. Okay, what was, yeah, I meant 3, sorry, my mistake. So I want the maximum between 3 and 3.98. Okay, that's where I want the maximum. Okay, and it is 3.29, comma 7.2. 3.29, comma 7.2. As expected, as you see, the function crosses here the y-axis, and it definitely goes more than, it does not turn here. I did not expect that the function to turn there. Okay, now we want to see this minimum. I'm going to say between 4.1 and 5. So second in calc, and that's a minimum between 4.1 and 5. Good, so give me the minimum. It's 4.7 at x equals 4.7, and the minimum is 12.8. So this function goes very, very close to the slant asymptote and really close here to the from the beginning, not down below. So that's it. And that is type 3. Good. Other questions? Is there anything else from chapter 3? Let's look at other problems from chapter 3. Let's look at a polynomial function. And for example, #41 on page 293. So we have a polynomial p of x, which is x to the 4th plus x cubed minus 2x squared. I would ask you to graph such a function. Ready? What is the domain of this function? Of course, all polynomial functions are friendly functions. I would like to factor this polynomial right away so I can determine the X intercepts and the multiplicities. What will you factor out?
Square.
Perfect. And then we have x squared plus x minus 2. How do I continue factoring? X squared plus x minus 2. What is the degree of this polynomial? Right? And how many, what is the max possible terms? Very good. How many x intercepts will you give me no matter what?
4.
Yes. So when p of x is 0, what do I conclude? So x equals -2, x equals 1, and x equals 0. What is the multiplicity of -2? What is the multiplicity of x equals 1? And what is the multiplicity of x equals 0? What do these mean? Just a regular cross. What does this mean? A term. Excellent. I put them in the chart. So I put -2 first, 0, and 1. So all of them 0, but just x equals 0 is a term. That is the x-intercept and the y-intercept. Now, can anyone tell us which function would you compare this function with in order to determine the end behavior? To x squared. Is it this or is it this?
It's positive.
Exactly, because the leading coefficient is positive. Very good. Some students in the past would come up with horizontal asymptotes for polynomial functions. So remember, we have not discussed anything like that. This is a continuous, smooth function, has no gaps, no jumps, doesn't go to a particular number. Right? It's either this, or this, or this, or this, depending on its degree. No asymptotes, no vertical, no horizontal, no slant, nothing, nothing. This is a friendly function. Okay. The only thing I need to determine is symmetry. But a function that crosses a -2 and 1 and turns to 0, it cannot be symmetric. So I'm happy if you just write, after you analyze this, and you just write f of -x does not equal f of x, does not equal -f of x, not symmetric. I'm fine with that. So that's all we need. This is a polynomial function, friendly, no asymptotes, nothing, nothing, nothing. So I start by plotting -2, 0, 0, 0, and 1, 0. And my chart tells me what to do. It comes from positive infinity. It crosses the x-axis at -2, 0. Then it has to turn at 0, 0, but it has to come to a minimum in order to come back and turn. There's no other way. And then has to come back to a minimum again because it crosses at 1, 0 and goes to infinity. So there are two local minima. I don't know which one is lower. I really don't. Not with what we know in pre-calculus. I won't be able to determine anything else. So this is P of X. What did I choose? X to the fourth. What was it? Okay, minus. Plus x cubed minus 2x squared. Okay. I need the graphing calculator in order to find the max and the min. So go to y equals and clear, and x to the fourth plus x to the third, of course, x to the fourth plus x to the third minus, minus 2x squared. So now viewing window, I can adjust it, and I should adjust it because I only care about -4 to 4 and scale of 1. Y minimum I can say, for now I'm going to say -6. And with the y maximum, I really don't care but that much because there is nothing up there that I need. So now graph. Here it is. Here it is. Excellent. So there is a minimum between -2 and 0, and the minimum between 0 and 1. And you see this is a cross, this is a cross, and this is a turn, as expected. So second in calc, I want minimum between -2 and 0 and enter. And the minimum is at -1.4, comma -2.8. And the other side between 0 and 1 with second and calc, and it's a minimum between 0 and 1, and it's 0.7 roughly, comma -0.4.
We're in a test, so we have to find all the minimums.
Yes, yes, because this is very important for applications. Being able to graph the function, understand the function, and be able to find optimization problems. Yes. Yes, and I would like, in order to give you an example of that, I would like to look at problem 22 on the same page. And problem 8 or problem 7, I let you decide. And of course, do I have to review the graph of a quadratic function? Okay, good. So let's read problem 22, because then I would like to review chapter 7. Is that okay? Okay. So in problem 22, a small shelter for delicate plants is to be constructed of thin plastic material. It will have square ends and a rectangular top and back. So it looks like this. So this is x and x, and this is y. So the square ends, so this is square, and the back is also a square, and the top is a rectangle with an open bottom and front, as shown in the figure. The total area of the 4 plastic sides total area is 1200 square inches. Express the volume of the shelter as a function of the depth x. So first of all, the first question is find a function that depends on x and that represents the volume. Okay? Ready when you are. Please suggest anything. Where will be the starting point here? What should I do first? What would you recommend?
Well, the shelter would be length times width times height.
Exactly. So perfect. So first of all, you are saying that you will come up with a formula for the volume, right? And you said, in other words, you said the area of the base times the height. And it doesn't matter how you consider the area of the base. So assuming this is the shelter, assuming. So I could say area of the base times the height, and I can say area of the base times the height. It doesn't matter, right? Or I could say area of the base times the height. So it doesn't matter how I determine the area, the volume. So it could be the area of this times the height, or it can be the area of this times the height. Doesn't matter. How do you want to write it? That's it. However, I have to eliminate y somehow, because this is a mistake. This is wrong. I wrote v of x, but this is not v of x. It's v of x and y. So I have to somehow eliminate y. Am I given anything? Can I use anything to eliminate y? Exactly. I am given the total area is 1200 square inches. So what does the total area mean? It has no base and it has no front. But it has back, it has top, and it has sides.
It would be 1200 equals 2x squared plus 2y squared.
Plus 2. So the two sides.
Not 1 squared, it would be 2yx.
Exactly. So one more time, let's do this together. This front is x times x. This back is x times x. But the top is y times x. And the side here in the back is y times x. We agree? Okay. So this equation, first I will divide both sides by 2. And I get x squared plus xy equals 600. And this should help me eliminate y. So I have to solve this equation for y. How much is y? I have xy equals negative x squared plus 600. And therefore y is but I have to divide by x. If you remember, I said never ever divide by x. True. But here x cannot be 0. So I'm allowed to divide by x in this situation. So negative x squared divided by x is, and then plus 600 over. Good. So now I can go back to the volume. And now this is not a lie. The volume will be a function of x only. It has x squared in front, and there is y that I put in parentheses and replace it by negative x plus 600 over x. And what should I do next? What would you recommend? We were asked to find a function that represents the volume. So what should I do?
Simplify it all, you distribute x squared over.
Negative x cubed plus 600x. I know all about this function. What type of function is it? I know how to graph it. I know everything about it. What type of function is it?
Quadratic function.
It's a polynomial degree 3, right? It's a polynomial. So degree equals 3. How many terms maximum can it have? Max 2 terms. Okay, very good. In the next, I close my book. What page was that? 200. Thank you. Sorry about that. The second question was, after we find, express the volume, yes, as a function of x, draw the graph. Okay, so we are doing part 2 right now. What is the domain of this function? However, you cannot say negative infinity to infinity because x is a length.
0 to
Exactly. So this time it has to be restricted to 0 to infinity. When x is 0, how much is the volume?
0.
As x approaches infinity, what will be the volume approaching?
0.
Careful. What will you compare this function with? It has degree 3. What will you compare it with? If it has degree 3, we compare it to the linear function. What is its leading coefficient? So will it look like this, or will it look like this? Like this. So what would be the end behavior? Right, impossible. Impossible, right? The volume could not reach negative infinity. But this is the function so far. We're going to analyze what happens here, and then we'll take this aside or erase it altogether. Okay, I need to determine the x-intercepts because I have the y-intercept. But now I need to determine the x-intercepts. So I have, how do I determine the x-intercepts? For any function.
Simplify 0.
Very good. Negative x cubed plus 600x equals 0. How do I solve this equation? What would you walk me through it? What would you tell me to do as the first step? Yes, I would even divide. And if you remember, I said never divide by x. True. In this case, I can because x is a length. It will never be 0. So I will divide both sides by negative x. So I have x squared minus 600 equals 0. Just this time, I'm not allowed to divide by x or negative x in general. But since I know that x cannot be a negative number, it cannot be really be 0 because the volume will be 0. What's the point? If the volume is 0, then I have no shelter. So now how do I solve this equation? Very good. And then
Square both sides.
take the square root from both sides, and I get x equals plus or minus, I'm expecting 2 solutions, 10 the square root of 6. So I'll approximate this 10 the square root of 6, or the square root of 600. What is it? The square root of 600.
24.5.
I'm sorry?
24.5.
Very good, excellent. So this is approximately 24.5 inches, plus or minus. But look what happens. I can put 24.5 inches here, but I really cannot put negative 24.5 inches, correct? It's outside of my domain. Perfect. Very good. So let's see. I should have not even graphed this side at all. So all I know is that the function has two X intercepts. I'm going to say that this is 10, 20, 25. So right here. Since both are crosses and it goes to negative infinity, this is not going to be the case. It's not possible. So this is the situation. Goes to a maximum, crosses, and goes to negative infinity. Of course, it makes no sense. This portion makes no sense. Why? Because this is a volume. So this portion of the graph doesn't tell us anything. Okay. So now in question C, this is part C. This is why I wanted to emphasize when Steve was asking, do I really need to determine these? Yes, for this.
I mainly just was wondering if we need to do both of them. It's not just like
Yes, yes, unless it's a symmetric function, and you say 2 comma negative 3, negative 2 comma negative 3. Otherwise, you have to determine both. Yep. So I have to determine a maximum somewhere here. Let's punch it in the graphing calculator. And y equals, there, it was negative x to the third. And I think it was plus 600x. Plus 600x. Let's go to the viewing window. I'm only interested from 0 to 30. I don't care for the rest. With a scale of 5. Y minimum, okay, negative 2. And Y maximum, I have no idea. This volume can go to 400, 300, 200, I'm not sure. I'm going to put 200. I have no knowledge of that till I see it. So with a scale of 50. It goes way up. So go back to window. I'm going to add a 0 in here with a scale of 100. Even that is not good enough. Okay? I'm going to add one more 0 with a scale of 1,000. Please. Ah. Beautiful. So it's right here, crossing a negative 24.5, going towards negative infinity. Who cares about that part of the graph? So I have to determine the maximum, and I see that the maximum is between, what was that, 30, between 20 and 40. So second and calc, maximum between 20 and 30. Uh-oh. And 20. Oh, it's 15, isn't it? What do I have here? 30. 5? Oh, a scale of 5. Okay. Okay. Yes. Okay. Between 10 and 20. Okay. 10 and 20. Yes. Give me the maximum. So the maximum for the shelter will be obtained when X is 14 inches roughly, and the maximum volume will be roughly 5657 cubic inches. That's why we study graphing polynomial functions, mainly for this, to be able to understand what's happening and how to find the maximum for a particular situation. So now if you have something like this, or you have a friend that says, okay, can you calculate for me, or what should I do, how should this and this be for a maximum volume, knowing that this is what I have, this is all the surface I have, plastic or otherwise, you can calculate, you can create the function, find its maximum, and say to your friend, listen, if you use 14 inches by 14 inches, and then y should be, where is y? Right here. Y equals negative 14 plus 600 over 14. And the length of that shelter, so what is 600 divided by 14? Because we are asked to find the dimensions. So 29 roughly. So if you use 14 by 14 with a length of 29 from the material, using the material you have, which has, this is our restriction. This is our restriction, that's all we have. This is the big issue. If we had more, we would be able to get a bigger volume, but that's all we have, and we have to play with 1200 square inches. So with the restrictions you have, you told me 1200 square inches. If you want a maximum volume, make sure that you use a 14 by 14 and the length is 29. And the maximum volume that you can obtain with what you have is 5,657 cubic inches. And now let's do problem 8. So the profit P in dollars generated by selling X units of certain commodity is given by the function. You should always rearrange it in descending order. Negative 0.004 x squared, and then plus 12x, and then minus 1500. What is the maximum profit, and how many units must be sold to generate it? This problem should take less than a minute. So I'm waiting for your response. So we're asked, this is the profit. We're asked, what is the maximum profit and how many units must be sold in order to obtain it? No, the vertex, right? Negative b over 2a, we have to find the vertex, and then p of that number. It has a maximum. It's a quadratic function with a negative leading coefficient. And we need to find negative b over 2a and then plug it in. Very good. And then I'd like to go to chapter 7. Okay, what did we get?
1500 is the y.
I don't have the answer. I have to divide 12. divided by 2 times a 0.008. Okay, 1500 is X, very good. So 1500 units must be sold to get a maximum profit. And how much is the maximum profit? How much did you get? Oh, I didn't square. Never mind. $7,500? Yes? Yes? Okay. Sorry about that. The calculator did not take the power. Or I went too fast through it. So the profit is $7,500. Okay, page 530. You will have trig equations. You will have identities. So problems 1 through 24. Problems 31 through 46. Problems 51 through 60. And 61 through 72.
Who's the second group of numbers? I'm sorry.
1 through 24. 31 through 46, I'm sorry, 31 to 46, 51 through 60, and 61 through 72. You choose. When it comes to identities, this is what I expect you to remember. Sine squared alpha plus cosine squared alpha equals 1. And the other two coming out of this, which is 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. Sine 2x, 2 sine x, cosine x. Cosine 2x, cosine squared minus sine squared, and the other two. Of course, when I say this, I also mean sine squared equals 1 minus cosine squared, right? Or cosine squared is 1 minus sine squared and taking square roots. Anything that involves these three. And tangent to x is 2 tangent x over 1 minus tangent squared. The lowering powers. Sine squared x is 1 minus cosine 2x over 2. Can anyone remind us cosine squared x? Very good. Very useful formulas. Very important formulas. Like the identities at the top, the sine squared plus cosine squared. Of course, from here, we have other identities like sine x over 2 equals plus or minus the square root of 1 minus cosine x over 2. But this is the same thing. I just changed x into x over 2, and I changed 2x into x. And I took the square root from both sides. It's the same identity. Of course, the other one with cosine x over 2 will be plus or minus the square root of 1 plus cosine x over 2, and it comes from here. It's the same identity. Once you know it in this form, you should be able to take square roots and change x into x over 2 and 2x into x. I can't think of anything else. Let me see, I don't want to forget anything. Oh, yes, I'm sorry. Sine alpha plus beta. This is the last set. Sine alpha, cosine beta, plus sine beta, cosine alpha plus beta, and tangent alpha plus beta. Of course, the other one with minus as well. I can't think of anything else. I'm going through just to make sure that I'm not forgetting anything. Nope, that's it. That's all you're responsible for. And of course, you will always be responsible for this. 1/2 the square root of 3 over 2, the square root of 2 over 2, the square root of 2 over 2, and the square root of 3 over 2, and 1/2. This is for pi over 6, of course, sine and cosine. This is for pi over 4, of course, sine and cosine. And this is for pi over 3. And everything else on the unit circle is not difficult because we remember the first coordinate is cosine. So this one here is 1, 0. So that's just cosine and sine. Here I have 0, 1, cosine and sine, and so on and so forth. That's all I'm expecting you to remember. So if you want 1, 2, 3, I consider all these together, and 4. And of course this one 5. That's all. Now, once you remember these are coming from here. So if you forget this, but you remember this, you can get it. Now, what if I forget this? Where do I get it from? From cosine 2x. Both come from cosine 2x. Because if you remember, I have 2 cosine squared x minus 1, or 1 minus 2 sine squared x. So no product to sum and sum to product. If I put something like that, I'll give you the formula. So this is what you have to remember. So now please tell me, what would you like us to do from the end of chapter 7? You will have trig equations, you will have identities, and you will have problems like the ones I mentioned from 51 through 72. You will have a word problem with some situation that requires us to determine something. Let's look at 32. Where is it? Very good. In problem 32, we have 5 cosine theta plus 3 equals 0, and this is on page 530. What do I have to solve for first? Very good. Cosine theta equals negative 3/5. Then I look at the unit circle. Where is cosine negative? Because there are 2 quadrants in which cosine is negative, so I have to have 2 solutions. Yes, infinitely many solutions actually, but yes. Good. So I know that they have to have the same reference angle. This and this must be the same. And here's one angle, this one, and this is pi here. And here's the second angle. Can anyone give us the reference angle? Because if we have the reference angle, the rest is easy. How do I determine the reference angle? Because I have no knowledge of an angle whose cosine is 0.6. This is 3 divided by 5, which is 0.6. I have no knowledge. So I cannot go back to my little chart because I have no idea what 0.6 is. So I have the equation cosine theta equals negative 3/5. What do I do to both sides to determine theta? Yes, yes, arc cosine or cosine inverse. So I apply cosine inverse to both sides. Absolutely. So let's go to the graphing calculator. Let's say I want degrees. So I have cosine of negative 0.6. Okay.
So you can cosine inverse, cosine inverse.
That's why I was looking, what is this? Second and cosine, of course. Negative 0.6. Thank you. 126.8. I'm going to say approximately 127. So theta, approximately 127 degrees. So now, since I am given this entire angle, so this is 127 degrees, the question is, how do I determine the other one? The reason why I determine the angle directly is because I have a negative number in here. If I had a positive number, I would have determined this little piece and then find the reference angle first and then find the angle. But I already punched in as I had it with negative. So I already have 127 degrees. So now I know the reference angle. What is the reference angle? So this is 180 minus 27. So 80 minus 27 is 53. Very good. So then I know that this reference angle is also 53. And now I know the angle, which will be 180 plus 53, 223. So now I can finally write the two answers. Theta, 233. Thank you. So now I can write the two angles. Well, actually, infinitely many. Oh, I shouldn't write 2 pi. I should write 180 because I'm using degrees.
The question, or the section says solve the equation in the interval 0 to pi.
Yeah, in this case, we can put that in parent. I didn't read the whole thing. Yes.
So I don't know where it is.
Yeah, there is no need then. There is no need.
Okay.
They only want this angle here that has the terminal side here and this angle that has the terminal side here.
Okay, and they say all solutions that would be plus.
That would have been that for all solutions. Very good. So then I have 127 degrees and 233 degrees, and that's final. Yes, this is a useful type of problem because we don't see in real life situations 45 and 60 and 30 that much. Perfect.
So it's for any future problem, if it comes out to we're looking for a cosine or anything of anything we don't have exact angle, if we can approximate it.
Yes, I'm fine with that. Yes, unless the problem is asking us to approximate to I don't know how many decimal digits. Otherwise, I'm fine. The mechanism that you apply is important to me than the decimals.
Okay.
Way more important than dot, 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 dot. Good. Okay, very good. Let's go back and choose. Is there anything else you would like to choose?
I think it was 68.
68. Very good. Yes, you will have a problem like that. No secret. I can hardly. I know I sound like I'm a broken record, like a broken record. Please redo all quiz problems. Please look at all homework problems. Okay. So 68. So sine, tangent inverse, 3/4 plus cosine inverse 5/13. This is that problem uses that last formulas that I listed, sine alpha plus beta. So I start with alpha. Alpha equals tangent inverse of 3/4. What do I do with this?
Sine alpha.
Tangent. Right. Tangent alpha equals 3/4. So I will look at the right triangle with an acute angle alpha. And I know something about the sides. What do I know about the sides? Very good. And then 3 squared plus 4 squared is 9 plus 16, which we know these are Pythagorean numbers. Very good. So now let's continue with cosine, and then we'll come back and fill in everything at once. So I have now beta equals cosine inverse of 5/13. What does that mean? That means that, yes, cosine beta equals 5/13. So here's beta and cosine. What is this? What is this? Good. So now I have 169 minus 25, which is 144. When I take the square root, that's another Pythagorean, a set of another Pythagorean numbers. Okay, so now I go back and I write what sine alpha plus beta means. So this is sine alpha cosine beta plus sine beta cosine alpha. Now I need to plug them in. What will you give me for sine alpha? Very good. What will you give me for cosine beta? Of course, we have it. Plus, what will you give me for sine beta? What will you give me for cosine alpha? Perfect. So now we perform the calculations as much as we can. So this is 15/42 plus, what is this? Is this 48 divided by 65? And the least common denominator will be 20 times, so it will be 260.
Shouldn't it be 3/5 instead of 3/4?
Maybe. What did I do? Sine alpha. 3/5, yes. Thank you very much. Sorry about that. So that's even nicer. Thank you very much. So this is 15 plus 48, and the least common denominator is 65. Excellent. So 15 plus 48 is, what is it, 63? Okay, so it's 63/65. Thank you. Perfect. Is there anything else from here? Let's look at 71. On 531. Looks very interesting. A 10-foot wide highway sign is adjacent to a roadway as shown in the figure. Okay, so perfect. As the driver approaches the sign, the viewing angle theta changes. Express viewing angle theta as a function of the distance x between the driver and the sign. So we're asked to find theta of x. Any suggestions? I have to evolve a trig function. I mean trig, right?
Theta equals tangent of,
You mean tangent theta
yeah, tangent theta equals x 10.
equals the opposite.
Over x.
Yes. Very good. How do I get just theta? I only want theta. I don't want tangent. Apply tangent inverse. Very good. So this is tangent inverse of 10 over x. And this is now a function of x. No doubt about it. Part B. The sine is legible when the viewing angle is 2 degrees or greater. So theta must be at least 2 degrees. At what distance, x, does the sine first become legible? At what distance x does the sine first become legible? So what do I do?
Theta equals 2 degrees, so 2 degrees equals tangent inverse 10 over x.
True. However, using this equation is much easier. But you're right, you're going to get the same thing. You put here 2, and then, but still you have to apply tangent to both sides to get it. So why don't I do this? Tangent 2 degrees equals 10 over x. And this is a proportion. And in a proportion, I'm allowed to swap. So this is x equals 10 over tangent 2 degrees. Or cross multiply and then divide, the same thing. So make sure that your calculator is in degrees. And then 10 divided by tangent, and in parentheses 2, and close, and 286 feet. X is 286 feet. Any questions? I recommend on page 532, the chapter 7 test, all these problems. I believe all of them have the answer in the back. So let me take a look. I will do all those problems in preparation for the test. Review 1, 2, yes, everything on the review, and then let me see the chapter test. Page 530, 532. Yes, all of them are in the back. I highly recommend this page. There are 10 problems. This covers everything in chapter 7.
Would you say do the same thing for chapter 3?
I'm sorry?
Would you say do the same thing for chapter 3?
Yes, absolutely. Absolutely. Is there anything else? I have about 14 minutes. Bless you.
Thank you.
Is there anything else you would like to ask?
We need number 10,
From
page 530.
page 530, problem 10. Very good. Tangent x plus cotangent x, everything squared, they say, is cosecant squared and secant squared. Very good. This is an identity. We are asked to show that this is correct. We know it's correct, but we have to show. And thank you for selecting one problem. Please do not try to fudge it, because I look at every step and I cannot give full credit. Okay? Please. Please. Okay, where do you like to start? I would recommend the left-hand side because it looks definitely more difficult than the right-hand side. Tangent squared plus cotangent squared squared. Oh, why did I put square? I would like to change it into sine over cosine. Sine x over cosine x plus cosine x over sine x. Once I wrote this, I already see the final. I already see how I get there. Which I did not see before writing this. And I hope you agree that the least common denominator is sine cosine. And I know you know what you need to multiply the tops by. What do I multiply the top of the first one?
Sine.
And the top, yes. And what do I get at the top?
Sine squared plus cosine squared.
Which is?
1, 1.
So now this is so much easier because I don't have to square a binomial. So I get 1 over sine squared times cosine squared. And now, yes, I peak, but that's okay. I need to. So what does this equal to? What is 1 over sine squared times 1 over cosine squared?
Cosine squared minus squared.
Very good. Is there anything else?
Can we go back to 7.1?
Yes.
Number 27.
20. 27 on 5, 27. Are we talking about page 498?
Yes.
Okay. Consider the given equation, verify algebraically that the equation is an identity, and then confirm graphically that the equation is an identity. In other words, what they're asking us to do is graph the left-hand side as a function and then graph the right-hand side as a function and just show that they overlap. Okay? Did you want the first part, the second part, or both? Okay, very good. So let's look at 13 I have here. So this is 27 on page 498. So first we have cosine x over secant x times sine x. They say this equals cosecant x minus sine x. So first they want us to show that the left equals the right. Okay, so I start with the left-hand side, cosine x over secant x times sine x. I can do anything to cosine and sine, but I can change secant into 1 over cosine. But when I divide a numerator, whatever it is, by a fraction, because this is sine over cosine, what do I have? Sine over cosine. So the numerator is cosine x over 1. The denominator is sine x over cosine x. How do I proceed? Flip. Very good. So then I have cosine squared over sine x. I do know something about cosine squared. How do I rewrite cosine squared? And I come back to the first set of formulas, the most important one, the most important set, in which if I have to solve this for any of the two, I have no problem subtracting one from the other, one or the other from both sides. So what do I write as cosine squared?
1 minus sine squared x.
This is a great privilege. When the denominator has only one term, I like it because I can separate the fraction. And I'm also peeking here a little bit, which is okay. So I separate the fraction into minus.
That's correct. X.
Very good. But I'm looking here, and I know where I'm going. So what is 1 over sine x? And I simplify one sine with another sine, and I have minus sine x, which I know is the right-hand side. So I showed this. And now for the second part, so I know that left equals the right. It's done. But if I want to show what they're asking us to confirm graphically that the equation is an identity. Okay, so let's go to y equals, clear. The left-hand side, which is y1, will be cosine x divided by, in parentheses, careful, secant x, which I don't have, so I have to write it as 1 divided by cosine x. Close the parenthesis. And close another parenthesis. Unfortunately, I need one more to insert one more in here. And then multiply it by sine x times sine x. And close the parenthesis. Now the second function will be cosecant x, which is 1 over sine. And then outside minus sine x. So now I have to use a viewing window for this. I am going to use the viewing, make sure that the mode is in radians now. So I'm going to choose a viewing window between 0 and 2 pi with a scale of pi over 4. How high and how low, I have no clue. I'm going to put -6 to 6 with a scale of 1. So when I graph, I should see a graph in blue and the graph in red. I have that chance or opportunity here. They come in 2 colors. The graph in red should cover the graph in blue. So I hit graph now. Let's see if I get anything. So here's the graph in blue. And here's the graph in red. Oh, not yet. And now the graph in red should be one on top of the other identically and perfectly because they are the same. And here it comes, it fills it in completely.
Yeah, my computer's, or my computer, my calculator's not in colors, so it's not that clear.
Right, mine, just the software, I think.
Yeah.
Very good. Any questions? Any questions? Okay, I'm not going to start chapter 4 in 5 minutes, but let's use the 5 minutes to do something else. For example, problem 6 on page 532. Problem 6. You will have a problem like this. We're given sine theta equals -4/3, and theta is in the 3rd quadrant, and we're asked to find tangent theta divided by 2. The problem will not be identical. However, for this problem, I would give an additional formula, which I'm not asking you to memorize. I would attach to this problem these two, which I never asked you to memorize these. So this or the product to sum and sum to product will be given. So I'm asked to determine tangent theta over 2, and I'm given sine. It doesn't matter which of these two I use. I still have to find cosine. So let's write 1 minus cosine theta divided by sine theta. So I have sine theta. This is already given negative 4/5, but I am missing this portion. How do I determine cosine? Cosine theta in the third quadrant. What is the sign of cosine in the third quadrant?
Negative.
So negative the square root of what? The formula is 1 minus, it's the first identity, sine squared. So then cosine theta equals negative the square root of 1 minus, and I have to square negative 4/5. When I square negative 4/5, I get positive 16/25. I subtract 25 minus 16 is 9. So this is negative 3/5. I have everything I need to determine tangent theta over 2. Can anyone dictate? The top. 1.
1 minus.
Yes, but it's minus minus, so plus 3/5 over. Very good. So the top is 8/5 multiplied by 5/4 with minus in front. So it's negative 2. Is it possible for tangent to be negative 2?
No.
Only sine and cosine are restricted. Everything else can be anything. Tangent is possible to be negative 2. Very good. Are we ready for this test on Wednesday? Okay. Are we going to be ready for this test on Wednesday?
It's
Please,
Maybe.
please, please, for me.
Steve, you have all the confidence in the world, man.